Hi, this is King of Review. So here we have a complicated logarithmic equation involving x, y, and z, and we're trying to find 11 to the x, to the y, to the z. So let's take a look at what we're trying to find first. We're trying to find 11 to the x, and then that quantity to the power y, and that quantity to the power z. But we know when we have a power raised to a power, we just multiply those exponents together. So what we're really trying to find here is 11 to the power x, y, z. Okay, so we know what we're trying to find. Now let's investigate this logarithmic equation. We have the log base 2 of x plus, now I know I can bring a number outside of a log into the log as an exponent. So this is going to be the log base 4 of y squared. And I can do the same thing with the 3 in the last log, bring it inside the log as an exponent, and this will be the log base 8 of z to the third power, and that all equals 1. Now there's something nice about these bases. All three bases are different. We have 2 in the first log, 4 in the second, and 8 in the third, but all of those numbers are powers of 2. So for example, I can rewrite the second log. Instead of base 4, I can write it as 2 squared. And in the third log, instead of writing base 8, I can write 8 as 2 to the third power, since 2 to the third power is equal to 8. And this is very nice, because since in the second log we have 2 squared as the base, and y squared as the exponent inside the log, those exponents can essentially cancel each other out. The same thing happens for the third power in the base and the third power on z in the third log. So I can rewrite these second and third log. The second log I can rewrite as just the log base 2 of just y, getting rid of the 2 squareds. And in the third log, I can rewrite it as the log base 2 of z, getting rid of the 2 third powers. And now I know that I have 3 logs, all with the same base, added together. And when I add together logs with the same base, I can combine those into one log by multiplying the 3 numbers from inside the original 3 logs, x times y times z. Now we're almost there. We know we want x times y times z for our original problem. We just have to get rid of this log base 2. And to do that, we raise 2 to the power of both sides of our equation. 2 and the log base 2 cancel each other out, and we're just left with x, y, z. And on the right side, we have 2 to the first power, which is 2. So bringing this back over into the problem I'm trying to figure out, I know I want 11 to the x, y, z, but now I know x, y, z is just 2, and 11 squared is 121. So there's our final answer. Thanks for watching.